Recording is on. Okay, so I have started the recording, and I think there is one more guy who has joined. So, okay, total three or four. Okay, so let's start my session. Can you just confirm you are able to see my screen?
No, I'm not able
Not
to
yet.
see.
Okay. Mm, Now,
No, sir.
okay. Again, I think the same issue. I need to just rejoin. So I will just rejoin in a minute. Okay. Sometimes that happens. Like I don't know also why.
Is Rakesh in the call?
अरे वो राखा
So Chris, Rakesh is not available.
अरे आए थे शायद मैंने उनका आवाज सुना
Hello.
Yes.
Yes, sir. Arpit, welcome.
Okay. So let me share my screen and just confirm if you are able to see my screen.
Yes, we can.
Yes, we can now.
Okay. Thank you. So let me start. So this is actually a beginner to intermediate. So I will start from the scratch and will try to cover the intermediate parts like some deep into the Kubernetes, and I will let you know where you can learn more. And if you want to be expert in Kubernetes, then just go through the documents and yeah, to be a expert you need at least a book to read. Okay, so in next 1 hour, first I will just brief me about myself, as there are some new guys attendees, and then we will go through the introduction of Kubernetes and what are the different deployments. Like there are what we have in traditional, then we go to the virtualization, and now we are in containerization world, and why we need Kubernetes, and the architecture of Kubernetes, Kubernetes concepts, cluster architecture, and implementation of Kubernetes, because we can implement Kubernetes in many ways. Okay, so about myself, um, I have at least more than 3 years of experience in various type of IT. Like I worked on started with the monitoring and then cloud computing like Azure and virtualization. Currently, I'm working on Hyper-V, and we are moving from virtualization to DevOps. So I have to work on Kubernetes, and in Kubernetes, actually, there are one more uh, tool, that is Rancher. If you, I don't know if you heard about this word Rancher. So yeah, I have worked on multiple dimension of IT, and why I am taking this session, because yeah, I am passionate about teaching and learning cutting edge new technologies that is coming in my ways. Like whatever, I am from the system administration guy, so I learn the new technology that is from the system admin perspective. So this session is also mostly on the Kubernetes administration rather than the development. Okay, so this is mostly focus on the administration part of Kubernetes clusters, and if you want to be a developer, so you can get a beginner knowledge of what is the Kubernetes, and then how to create pods and how to write YAML manifest to create a pods. So those things you can learn from here. So if you are a developer, you can also join and learn the, if you don't have any knowledge about the Kubernetes. Okay, and I like to listen Punjabi songs because already know. Okay, that's it from my side. And so, introduction to Kubernetes. Why Kubernetes? Because we already have a Docker, right? So why we need Kubernetes? Because actually Kubernetes is a orchestration tool. It is not a container runtime application. Okay, it's a orchestration tool, and you can use any runtime container that you want, like Docker, Rocket, or CRI, whatever you want. Okay, so it is going to orchestrate the container applications or pods. That's called pods. Okay, so it's a open source orchestration tool to manage the containerized workloads. So whatever the application that you want to containerize, you can handle it using Kubernetes. So you can scale up, scale down your applications, and you can automate those scaling using Kubernetes. Okay, and what is the meaning of Kubernetes? Actually, it's a originated from Greek word, and that means pilot or helpsman. So helpsman is like, who steers the ship, or what is the other word? So just remember the who steer means who is going to control all the things, because ship is like a these things are coming from the Docker world. So if you see the images of Docker, you can see it's like a ship on which the containers are floating over there. So Kubernetes is like a pilot who is going to uh, drive the ship, or steer the ship. Okay, and actually it is started by Google, and then it become open source in 2014. Before that, that is the property of Google, and they are developing a tool that can handle their workloads, and that is able to uh, uh, scale up or scale down automatically. Means there should not be a less human intervention, you can say. And fourth point is platform independent. So you can install on Linux, Windows, or there are multiple public cloud as well. So you can run the Kubernetes cluster on Amazon, Azure, Google. So those are the managed containers. Means those are managed clusters. So the underlying hardware, whatever they use, you don't have the control on the underlying hardware. Okay, so you can just have control on your Kubernetes clusters. So that is not the case. Means if you it depends upon how you have implemented. Like if you have taken some virtual machines and then you have installed the uh, your Kubernetes, then yeah, you have some control on the hardware, like how much resource of one node or master node you can increase the resource, like from 2 GB to 4 GB, 4 GB to 8 GB. Those controls you have. But if you are using a managed cluster like AKS, that is Azure Kubernetes Service. So that is a service, as a service. So you don't have the control on the underlying hardware. Okay, and if I say supports on Windows, so you can install Minikube on Windows. But if you have to install all the binaries of Kubernetes, then yeah, you cannot do it on Windows. You have to use Linux. But you can add a worker node. So I will explain what is the worker node and master node. So you can install Kubernetes on Windows, and you can add it as a worker node, but control plane should be on Linux. Okay, but yes, one more exception: if you can install Minikube, that is a implementation of Kubernetes, that you can install on Windows. So that is called single node cluster. We will discuss more on those things. And actually, uh, it says that Kubernetes can only handle the application containerized application, but that is not the case. You can handle you can support these stateless and stateful data processing application. The main condition is this application should be running as a, it can run as a container. So if it can run as a container, you can run it on the Kubernetes. Okay, and can integrate with CI/CD workflow. So if you have some, you can use continuous integration and continuous deployment using Jenkins. So you can deploy your code instantly, or you can say in a agile method to the Kubernetes cluster. Okay, so you can integrate your Kubernetes cluster with CI/CD model. And next one is, yeah, it's easier to use and more powerful, robust. So why we use this instead of Docker Swarm, we are going to Kubernetes, because it is actually provide more resiliency and extensible, and it is more robust. And how it is more robust and powerful, we will learn actually when we do the demos, and you will understand. And if you have attended the Docker, then you can differentiate between how it is different from the Docker. Okay, and why we should use Kubernetes instead of Docker. Okay, Docker Swarm, I mean. So that is the simple introduction of Kubernetes. Let's go to the next slide. And here we have a difference between traditional, virtualized, and container deployment. So actually, in traditional way, it means like I have a physical machine and I have installed operating system on it, and I can install multiple application on the same operating system, right? But here the problem is, mostly we cannot run multiple application on the same operating system. So that becomes very difficult, and we are not utilizing the hardware at the truly, right? So we go from hardware to virtualized deployment. So we have one, we have physical machine, we have installed operating system, and then on top of operating system we can install hypervisor. So here actually you can install hypervisor directly on bare metal, means on hardware itself as well. Okay, but this image is like, if you are doing virtualization on your own operating on your machine, on your laptop, so in that case you have to use hardware, and then you have to install operating system on it, and then you can use any hypervisor like from VMware and Hyper-V, whatever you want you can install. And on, if you once you install the hypervisor, you can virtualize your hardware using virtual machine. So you can install virtual machine on it, and now you can install the application. So you want to install some application on this virtual machine, some on this virtual machine, so these are actually isolated. So these the binary and all the, this is actually full blown operating system whatever we have installed over here, right? So now to install operating system we need some hardware resource on hypervisor, right? So this is the, not a, you can say, truly we are using the we are actually, there is a redundancy of operating system, right? Means if I have 100 or more than 100 machines, I have operating system installed on all the virtual machines. So about those, the redundancy of operating system is on all the virtual machines. So the resource that is used by the operating system, that is actually not useful, because to just run an operating system I need 1 GB at least. So just guys, can you just mute yourself? So here, to remove this redundancy, we have a container deployment. Okay, so what we have done is, you can see here I have installed operating system on hardware, and then I have installed again, instead of hypervisor, I have installed a container runtime. So it might be your Docker, Rocket, CRI, Container D, okay, whatever. So I have installed that, and that is actually a lightweight. Okay, and now I can run multiple application on this using this container runtime. And again, these application are isolated, means this container doesn't have any information about this. So these are their own file system, networking, namespaces, everything has their own. Okay, so those are isolated. And we have removed this operating system redundancy from the virtual machines. So actually we are utilizing some more resources, and whatever the resources yeah, reserved for these operating system, that we have removed, and we can use it in our application, right? So this is how we have utilized the physical machines, okay, or resources to more than actually, if you are using containerized deployment, you can utilize your resource about to 80%. Okay, so here in traditional we have about 15 to 20%. Here we have 40 to 45%, but here we can use 80%. Okay, and how we have used, actually I have more discussed in earlier session on Docker, so you can go through the session and check how you can actually containerize your application and utilize the resource. And other things, instead of installing utilizing your resource, there are multiple other things that we have to consider why we should use the container. Okay, that will come in the next session, sorry, in the next ppt. And yeah, so why we need Kubernetes. Okay, so this is actually why we need Kubernetes. So first one is service discovery and load balancing. So there is actually a DNS, or by default, that is installed by the Kubernetes. So the services is in terms of uh, Kubernetes service. So whatever the Kubernetes service or pods and containers, volumes, those are actually defined by there is an entry in DNS. So those resources can be discoverable using the DNS. Okay, and you can say as a using a name. You don't have to remember the IP, but internally, if they want to talk to each other, they use this service discovery. And if Kubernetes thinks like this container has more traffic, it will automatically load balance that traffic to the other pod. Okay, so here I am saying pod and containers. So actually, pod and containers are a little bit different. So in container is used in the Docker world, but in Kubernetes we have to use pod. So container actually reside inside the pod. Okay, so there are multiple containers in one pod. So just remember this thing, because you might confuse why I'm using container and pod. So this is the main difference of between pod and containers. And storage orchestration means you can automate the mount of the volumes using Kubernetes. So you don't have to manually go and mount the things. Okay, you can actually use the Kubernetes to mount your storage, like local storage or any public cloud, whatever. Okay, so whenever it needs, the Kubernetes will automatically mount the storage from the local storage or somewhere. So we will learn actually how to automate these things, but just for your reference, or just keep in mind, like we have these things in Kubernetes. Okay, and how we are going to do it, actually we will discuss in coming sessions. So automate rollouts and rollbacks. So we can actually automate our rollouts, and if we have a upgrade of our application, what we can do using Kubernetes, we can deploy our updated application in such a way, like I don't want to just deploy a new application. Okay, so what I will do, I will create some new pods using a new updates, the whatever the new updates. So I will create the pods using that new code, and if that is working fine and everything looks good, then what I will do, I will create new more pods, and once that is ready, I will delete the older version of pods. Okay, so the pods that contains the older application, I will just remove it from the cluster. Okay, in that manner you can actually very smoothly you can update your applications. Okay, and automatic bin packing. So you know actually, whenever you create a pod, you have some specification that you give into the YAML manifest, like how much resource this pod should use. So the Kubernetes will check and automatically check for the all the available worker nodes, what are the best suited node for this pod. So on which pod this on which node this pod should run. So those automation is actually maintained by the Kubernetes, means you don't have to think about on which node I have to run this pod. That is managed by the Kubernetes, and that is the orchestration that we have to use in using Kubernetes. Okay, and self-healing. So self-healing, actually this is the feature that I like most, because if you have a virtual machines, then you can, there is no option to self-heal the virtual machine, right? Actually we have to recreate the virtual machines, and it takes about more, at least half an hour to create a new virtual machine and attach the old vsdx. And then, but in Kubernetes, if your application is running as a pod, then if there is something wrong with that pod, like for high availability, what we do is we have more than one pods for one service. Okay, or one deployment. So if there is issue with one pod, the Kubernetes will check, and we define why, when it the Kubernetes will find like this pod is not working. Okay, or it has some issue. So we define these things in the YAML manifest, and then the Kubernetes will check, and if Kubernetes thinks like this pod is not working, it try to, or if the pod failed, it will try to restart it. If Kubernetes fail to restart the pods, it will just destroy it or kill it, and it will create a new pod. Okay, so I don't have to think about anything, just I have to give the what I need three pods of this deployment. That's it. Kubernetes will take care. If there is any issue with one pod, it will just try to restart it. If it fails, then it just destroy that pod and create a new one. So there is no human intervention, right? It would automatically do those things. So that is a self healing. It try to self heal itself. Okay, then secret and configuration management. So in pods, or if we have a multiples deployments, like one deployment for web application, another for db. So I have to give the secrets or password to the web application to connect to the db pods, right? So in that case we cannot write the uh, password in a human readable form. Okay, so what we use, actually we use secrets. So we have a secrets Kubernetes, in Kubernetes, so we can create secrets, and we can encrypt the password using secrets, and we can use that secret in the YAML manifest. So those secrets will be maintained by Kubernetes. You don't have to worry about it. Okay. So your password and whatever the confidential thing, you can keep it in the secrets. And configuration management is like in this way, you don't have to, like I have some image that I have created, and there are some password that I have to mention. So if I want to change it, in that case I have to rebuild the image, right? Because I have to change it. But if we are using secret, we don't have to rebuild the image. We have to just update the secret, and it will automatically reflected to the image. Okay, so that is the secret part. And go to the next slide, and this is the block architecture of Kubernetes. So what are the components we use in Kubernetes? So we have this Kubernetes control plane. So in Kubernetes control plane, we have these actually four components, but there is one more, that is cloud controller manager, and that is, sorry, so that is actually after 1.6 version. So it is come as a alpha testing in Kubernetes version 1.6. Okay, so I will discuss about it later. So first go from this Kube API server. So what is the meaning of Kube API server? So actually, this is the main component of control plane. Okay, so whatever the things is going to communicate, so like these kubelet, kubeproxy, these things have to communicate using API server. So kube scheduler, it is also going to communicate to the API. So whatever you want to change in your cluster, you have to go through this API server. It actually exposes the API of the Kubernetes. Okay, so you can connect to the Kubernetes. So this is the main kube API server. So whatever the data and is needed by these kubelet or kubeproxy, it will query to your kube API. And then kube API can only communicate to the etcd. So next thing is etcd. This is a data store, and this is not only it's actually a open source project, etcd, and that is known for the uh, storing distributed store of if you want to store some key value pairs, you can utilize etcd, and it's a distributed data store. So Kubernetes actually uses etcd to store the information of the cluster and nodes, everything in the etcd. So whatever the things these components needed, it will ask to API server, and API server will query to the etcd. Okay, so no one can communicate directly to etcd. First we have to make a API call to the kube API server, and then it will check in the etcd, and it will give the data whatever needed to these services or components. So second one is kube controller manager. Before that, just go to this queue scheduler. So what is the meaning of queue scheduler? What it does? Actually, whenever we create a new pod, right? So we have a YAML manifest that we have created, and we give some specification like how much memory it should use, the CPU details. So those things has been configured in the YAML manifest, and queue scheduler will check all every time it watches for a new pod. So whenever a new pod is getting created on the in the cluster, it will check and it will decide on which node. So these are the nodes, worker nodes. So on which node this pod should run. So it will search for the best suited node for that pod. Okay, so this is the main work of this cube scheduler. So it is not going to schedule anything. Actually, it just searches for the best suited node to run the newly created pod in the cluster. Okay, and now go to the kube controller manager. So kube controller manager is actually, it runs multiple controller processes, and there are you know uh, four controller processes. So those run as a single binary, that's we call kube controller manager. But inside it is a comprised of four controller processes. So one is node controller. So that I haven't actually write in the PPT. So just let me write over here. So first one is node controller. Second one is replication controller. Third one is endpoints endpoints controller, and fourth one is service account and token controller. Okay, so these are the four controller processes. So Q controller manager actually runs these four controller processes. So manager is actually comprises of these four controller processes. First one is node controller. So this is actually self-explanatory. So this is uh, it will check for the nodes. Okay, these are the worker nodes. So it check the nodes, the node is up or not. If any node controller goes down, so it will check for that. And if that controller is not up, then what about the other, the workload that was running on that controller? Okay, so what should do for those workload? So it will just distribute the workload to the other up that is to the other nodes that is currently running. Okay, so it will check the nodes. So in short, you can say it will check for the node status. Okay, and second one is replication controller. So what are how many pods or in the system we have some these things are running as a pod as well. Okay, these cube scheduler API server, so these are running as a pod. So this replication controller will responsible for maintaining the number of pods. Okay, so how many numbers of pods we should there should be. Okay, so those things are defined by us, like how many pods we need. So it check for those pods. If there is less pod, then it will maintain the number of, and it will how it will maintain, it will just create a new pod, right? So this is the res- responsibility of replication controller. Then endpoints controller. So endpoints, I think you aware of in the last session of Docker, I have discussed about this endpoints. Endpoints is like, a point to connect to the container, right? So the endpoints that is there in the controller, or sorry, on the in the container or pods. So those things, those endpoints is managed by this endpoints controller. Okay, and service account and token controllers is again the same. uh, there are some whenever you create a new cluster, okay, new Kubernetes cluster, there are some accounts that is getting created by default. So those accounts and the API tokens that is created. So actually these things are in the deep, because when we will implement the Kubernetes cluster, uh, you can understand when we can do it from the scratch. Okay, but we are going to use some pre-built solution to implement the Kubernetes cluster. Okay, so in that case, these things you will really are confused with. But just remember that whenever we create a new Kubernetes cluster, we have some default service accounts. Because whenever to communicate with these API server, there are some tokens, server account, right, to authenticate. How it will authenticate? So by default, when we run the commands, we think like we are just running the command, but behind the scene there are some default service account tokens and certificates that is working, okay, to authenticate the user. Otherwise anyone can run the commands, right? So there are some default service account guys created for the uh, managing the cluster, and you can create other accounts as well. So we will create some service account for RBAC or role based access control. So then I will discuss more about this service account and token controller. Okay, so these four components is main component that everyone will tell you, but there is one more that is cloud controller manager, I think, and this is come as a alpha feature in release 1.6. So it is actually, I have taken this a snapshot from Kubernetes documentation, so that's why I have this cloud controller manager. So this is actually just to, the if you see here, it is connected to the cloud. So as I said, there are some mm, uh, managed cluster that is provided by the public cloud like AKS, EKS, and JKE. Okay, so AKS is Azure Kubernetes Service by Microsoft, and EKS is Elastic Kubernetes Service that is from Amazon, and the third one is JKE, that is Google Kubernetes Engine from Google Cloud. So these are the some cloud. So if you have some cloud things or some cloud clusters, then you those things will be managed by this cloud controller manager. Okay, and really I also don't have much information about this. So you can go to the documentation and run, you can read from there if you can, if you have to learn about more this cloud controller manager. But in long story short, it just to control the cloud managed clusters. Okay, so if your cloud cluster or cloud Kubernetes cluster wants to try to or you want to integrate your on premises cluster with the cloud, so this will be used cloud controller manager. Okay, and here this is the actually node components. Okay, so this is called control plane and the main Kubernetes components, and this is the Kubernetes node. So these things will be run on the worker node. Okay, so this part will be on the master node and this will be on your worker node. So first one is kubelet. So kubelet is actually, it is used to run your pods. Okay, so it actually responsible for like the pod, there is a container running inside the pod. Okay, so it checks that container is running or not in the pod, right? So this kubelet is not it is installed as a binary. Okay, you cannot install kubelet as a pod because this is responsible for the pod. Okay, so the containers are running on the pod or not. So this kubelet cannot be run as a pod, but kubeproxy, this is actually run as a pod in your cluster. Okay, so kubeproxy is responsible for the to communication from here to API server. Okay, so it has some network rules and net services. So we will discuss about the node port service and those things in the coming session. So these things in the coming session I will discuss, not using the PPT or something. Actually I will discuss while doing the demos. Okay, so just remember that from the next session there are no PPTs. So for to learn more or to understand more about this Q proxy or whatever, so you have to read the documentation. Okay, but how it works, that I will show you. Okay, so there is one more component that is main thing is container runtime application. So one more thing is it might be Docker, containerd, Rocket, anything. But yes, there is one more component that is called container runtime application. Okay, so this is the basic architecture of Kubernetes. And if you go to the next slide, I have written the same thing, and I think I have discussed all the component of Kubernetes. So this is these are five is on Kubernetes control plane. So these are the components of Kubernetes cloud plane and Kubernetes control plane, and these three are the components of node components. Means these three will be run on your worker node. So
Sarabjit,
let's go. Yes, yes, yeah.
Sarabjit, I have a question.
Mhm,
See,
mhm.
what is the difference between this kubelet and kubeproxy? I'm just confused. I mean, both of them communicate with the API server, or only the kubelet communicate, or how it is?
No, no, both can communicate. Okay, but proxy is actually responsible for networking part. Okay, so the implementation of networking, like we have some pods. So if I want to access those pods, okay, so we have some networking things that is running behind it. So we have to use node ports and other things. And proxy is also to it provide the communication from node to worker node to the master node. Okay,
Okay,
so how this worker node will communicate to the master node, that is defined by proxy. Okay, and kubelet is actually it will the things whatever you need, it actually go from proxy then API server, right? And it mainly used for the responsible for the pods, right? So the pods, if there is any pods is running, so in a pod there are multiple containers. Like you it is recommended to just use one container in a one pod, but this is not mandatory. Okay, you can run multiple containers in one pod. Okay, so if it is responsible for that the container I have defined to run in the pod, that container is running correctly or not. Okay, if I have defined to run two containers in a one pod, so both the containers are running fine, is it good or not? So it will just go for the API server whatever we have defined. Okay, so kubelet will just actually it goes from here, the this picture side, that it will directly communicate from here to here. But from my thing, I think it will go from proxy and then it will go to the API server. Right. So
okay,
uh,
okay.
uh, tomorrow when I will install these packages and binaries, I will discuss more about this. Okay, and I will show you in the working how it works. Then I think you will understand properly or in depth. Okay,
Yes,
so just right now, just remember that this proxy is mostly responsible for networking part, and kubelet is for pods. Okay, so right now this is the main difference. Okay,
yes,
so this is the same thing. So this is the cluster architecture. So actually, this is the cluster architecture of highly available or load balanced cluster. Okay, so these are three master nodes. Just remember, and in our environment, I am going to create one master only and two worker node. So this is to learn, and cluster architecture is like master and worker nodes. Okay, if I say cluster architecture means I'm talking about the master and worker nodes, how it is architect. So in highly available scenario, we have more than one master. Okay, and these API server actually load balance. So there are multiple nodes, like in one cluster there are many worker nodes. So in that case, it is not possible to handle this query to one single API server. So we have multiple API servers, and those are load balanced. Okay. And here is the same scenario. You can see uh, if this node component or the worker node 1, it has the node components. Node component means these three things: kubelet, kubeproxy, and container runtime. So it will go to the load balancer. So there is one more server, that is nginx server or something, that is going to redirect this route to the three different master nodes. So this, if this worker node call for there is any API call from this worker one, it will go to load balancer, and here it goes to any API server. So let's say it goes to this API server. So then it will, scheduler will check the API server. So whatever the scheduler needs, it will again query to the API server. Because why everything is communicating to API server? Because this API server has the only communication with etcd, and here the data is stored. Okay, so anyone who wants any details or any information, it has to carry to the API server, and API server will check to the etcd and data store, and it will reply back with the details or information. Okay, and here the main thing is, you cannot run multiple instances of control manager. Means you can run, but at a time one will be active, only one will be active, other will be in the standby. So here I have written the note that scheduler and controller manager are active only on one node at a time. So this control manager is active on master 1, then these two will not be active on the master 1, master 2, and master 3. Why? Because like scheduler have like controller manager, let's say controller manager want to have the responsibility of control other things, right? So there might be some that is called DSC, desired state configuration. So this will try to do the pods, like I have to run 3 pods of a service or deployment. So this control manager will also try to uh, go to the desired state, and this will also do the same thing. So there is actually a competition going between these 3 or 4, whatever, how many master you have. So to remove that conflict, we there is only one controller manager and scheduler should active at a time. Okay, otherwise there are multiple or duplicate objects might get created on your nodes. Okay, that's why we have only one controller manager and scheduler active on one node at a time. Okay, so if, and this is decided by the leader. Okay, so if something happened to this master 1, so there will be a election between master 2 and master 3, who will be the leader, right? So once the election is done, then let's say master 3 will become the leader. So control manager and scheduler, this will become active, and other two will become the passive or standby. Okay, so these two will not work, only one will work. So this is mostly for the consistency. Okay, because these things are writing to etcd, right? So it will take information from here, and there might be some time difference, right? Because everything is writing to this etcd. So if there are multiple control manager, then there are chances to create some duplicate objects. And when I say object, it means like any deployment or pods or anything. Okay, so this is the cluster architecture of highly available cluster. And this is the last slide for today's session. So implementation of Kubernetes. So this I was talking earlier. So we can actually implement Kubernetes in three ways or other as well. But I have this first one is custom. So when I say custom, it means you have to create all the things by yourself. Like, we have those four components, right? So if you install using QADM or other built-in solution, pre-built solution, then those things will be automatically installed. But if you are doing that's called the hard way. So if you're doing in the hard way or using custom, then you have to install those binaries. First you have to create some certificates for authentication that I was saying in the earlier slides, right? Because we think like there is but there is some service accounts and certificates that is going behind the scene, but we don't have knowledge about that, right? But if you are doing installing your Kubernetes from scratch, you have to maintain those things by yourself. Like you have to create the certificates, you have to install the binaries, then after putting those binaries to the correct location, then you have to create the service D, because there is no service D by default. Okay, you have to create your own service, like controller service, scheduler service, API service. Okay, everything, QAPI, Q controller, everything, you have to create a service. Okay, and then you have to same do for the node control, node components as well, like kubelet, proxy. So those things you have to install and create service by your own. Okay, etcd whatever. So you have to everything you have to do. But there are some pre-built solution like minikube. So minikube is actually a single node cluster. So if you install on, you can install on your own laptop. So what if you are using, you have a single, if you have a laptop, you can just install minikube and you will get the Kubernetes cluster. So that's called a single node cluster. So it is mostly for developers. So they want to test something, and so it will just create a single node cluster using minikube, and those certificates and other things, those you don't have to worry, that will be taken by the minikube. So those are the pre-built solutions. So there are miniseft as well, and I think ubuntu on lxd. So if you need pre-built solution, you can. And some public cloud, so you can use the EKS, AKS, JK, etc. So those are the services, or you can say Kubernetes as a service. So those public cloud or vendors are providing Kubernetes as a service using this AKS, sorry. So EKS means Elastic Kubernetes Service. So this is from Amazon, and AKS Azure Kubernetes Service from Microsoft, and JKA is Google Kubernetes Engine. So this is from Google. So you can use these public cloud as well. So just you have to go to the public cloud, any of the public cloud, and just click on Kubernetes Engine and JKE, or you have to just give how many worker nodes and master node you need, and what are the configuration, like the worker node have 2 GB RAM, 4 GB RAM, how many CPU you want. So those things you have to just uh, provide on the dashboard, and then just click create cluster, and it will create a cluster for you. So again, you can just start your cluster within a few minutes, like it takes about 10 to 15 minutes, and your cluster is ready to use. So uh, if you want those, and again, you will get the other benefits of public cloud that we get. So it depends upon you how you want to implement the Kubernetes. Okay, and in ours, session, I'm going to install it from the scratch, but not as a custom. Okay, so I'm not using any pre-built solution, but also not the custom. I'm using actually QADM, and the QADM is a tool that is used to, just easily install or easily start your cluster. So the things that I mentioned, like creating certificates, default users, okay, and some etcd and components that we need. So those things are taken care by kubeadm. So we have to just install kubeadm, and then we have to initialize the kubeadm, and we are ready to go. We can start our Kubernetes cluster, and we can work on Kubernetes cluster. Okay, so that is the implementation that we are going to see. So that's it from my side. If you guys have any question, you can ask right now, or we can wrap up and we will start from tomorrow at the same time. So is it okay with you guys?
Yes, Sarabjit. Just
Yes, sir.
uh, basically, what is Minikube? It is, as you said, it is a pre-built solution. I mean, what kind of
Pre-built solution.
Minikube? Minikube. What is that? Minikube.
Actually, this is a pre-built solution that we call, means, you can just like say you have a only a laptop in your that you have, okay, and you want Kubernetes, but Kubernetes to be installed on your laptop. So in that case, easiest way to work with Kubernetes cluster is just install Minikube, and whatever we have talked in this session, like these components, and these are the components, kubelets. These are the managed by this Minikube. So in our scenario, we are going to actually install these things like controller manager. So we are going to install using kubeadm, and we have to install kubelet, container runtime. Okay, but if you want to use Minikube, then just you have to install the Minikube on your system. So you can go to Google and search for Minikube and download Minikube and install it. That's it. So this is the documentation for Minikube. So this is mainly used for development or testing purpose. Okay, just keep in mind that you cannot use for the production scenario. It is only used for the. So make sure this is from Linux. Actually, there are one Minikube for Windows. So if I write Minikube for Windows, I will get. So here it is, Kubernetes Minikube locally. So you can run the Kubernetes on your local computer or local laptops. So otherwise, if you are using kubeadm, then you need more than one uh, laptop or physical machines, right? Or yes, you can do it on a virtual machine. Yeah, that's a other way. But again, you need more than one virtual machine to be used in using, if you are using kubeadm. Okay, but if you are using a Minikube, you can simply install Minikube using on your single laptop. Okay, and you don't need multiple laptops or physical machines. So here using VirtualBox or Hyper-V. So you can see .exe. So you have to just install Minikube. That's it. Don't have to do anything.
So yes,
So
so basically it will have everything what we, I mean, what we have in masters. I mean, pre-built control manager.
yes, yes.
So
So oh, like we need a runtime container, right? So here, if I am using a mini cube, then that will be installed automatically. Means if I don't know that we need a Docker runtime or any container runtime, so you can simply install mini cube. Okay, but you don't know about anything behind what happened behind the scene. So mini cube by default is actually using, it uses Docker. Okay, so let's say I want to use, I don't want to use Docker, then what I will do in that case? Again, I cannot use the minikube because minikube is going to install Docker by default as a runtime, container runtime. So these are some pre-built, so everything is already configured and you don't have the control on it. So just you want the default settings and whatever is there inside it. So here you can see creating CA, right? So what is it? It is a certificate authority. So it is creating the files, certificate files, and then it will it will move these files to proper location by itself. So you can assume it as a like a YAML file actually, that it has automated things to do, like it is already written where to create the files and where it have to put those files. Okay, so those things automatically done by the or pre-configured where what to do. So once, so first of all I say it will create a CA, then it will distribute that CA to the different nodes and worker nodes, and then it will creating SSH networking. Again, yeah, if you are using kubeadm, you have to install cube networking plugin. Okay, but if you are using minikube, you don't know about what are the network plugin that is used behind the scene. Okay, so those things are actually defined by the minikube, so you don't have to worry about. If you just want that I need a Kubernetes cluster and I don't want or you don't know anything about Kubernetes, but you need Kubernetes to be run on your laptop for testing purpose, or for if you are a developer, you want to develop it, you don't want to know much about the Kubernetes, then you can use Minikube or Minishift. There is one more Minishift. I think OpenShift is also the same. I'm not sure. So here you can see the, go to the Windows download link shown below. So you have to go to this link and you can download the Windows version AMD16 and you can run it as a .exe. Okay. I don't know if I can. Actually, this is the image. So here are the binaries. So here you can see where you want to install. If you want to install on a Windows, you will find, you can see these installer.exe. This is for Linux, this is for Windows. If you want to install on a KVM, you can. These are the different versions. So right now it has 1.7.3. So if you want to see, I can do one thing, I can download it, but I think it will take some time. I don't know. Okay, 3 minutes, 2 minutes. Okay, let's download it and we will run this mini cube over here. Okay, and tomorrow we will go for the kubeadm. Okay, so mini cube I can install my on my laptop, but if I want to use kubeadm I cannot do that. Okay, I need multiple machines, at least one worker and one master and one worker. So if someone asks you like you can create a cluster without a worker node, then yes, you can create a cluster with one manager or multiple manager with zero worker or multiple worker nodes. Okay, so here you can see the usage of minikube dashboard. So if I use this dashboard command, I will get a dashboard. I can delete the local Kubernetes cluster, Docker environments, and K8 Kubernetes versions, IPs, logs, config, services. Log into your run or run a command on a machine with SSH similar to Docker machine. And yes, you can manage your cluster from a remote machine. Means I can install, just I have to install the kubectl, so I can install kubectl on my laptop, and I can manage my cluster that is on public cloud or somewhere using SSH. Okay, so I have to do some configuration like context and those things I have to do, and then I can use or I can manage multiple cluster from my one single remote machine. Okay, so just remember that we can do that as well. Just we have to use the context, on which context, or context means a cluster actually, in which cluster you want to run the commands. So start command is start the cluster, and once it is started you can run the. So here you have to give which version of Kubernetes you want to install, and VM driver, like you want to use VirtualBox or something, because behind the scene it will create some virtual machines, small virtual machines. Oh, let me open the PowerShell. PowerShell, and so I have just pasted my minikube installer on C column. So let's change my directory, and if I see here, you can see minikube installer. Okay, actually this is the installer, so it will install minikube, and then we can. So this is a simple setup. I have to install this. So it goes to program files, Kubernetes minikube. That's it. So if I change my directory to program C colon program files and Kubernetes. So here is the minikube.exe. Okay, now I can run the commands. So first, I just want to check the version. I have to run this. So right now, just minikube is just installed. Okay, Hmm. So let me open the file explorer, and if I go to Kubernetes, okay, that's the problem. Actually, here you can see this is the directory, so that's why it was not working. Okay, now we have minikube.exe, so now I can run the command. Okay, it's 1.7.3, and how many what are the versions of Kubernetes it support. So if I want to know about that, I can run this command, or if you don't have the internet, then you can just run help. Okay, you will get all the commands like uh, okay, and if I run this, oops, I think it will use hyphen hyphen because it is a flag. It should. I don't know. The help is, so here you can see they might have changed the commands, because start is correct to start a local Kubernetes cluster. Stop. So if I run, I want to create a cluster, okay, and I will just have to type minikube start. So it will create, you can see, and I'm really sorry, but it's one, how much data? It's a 167 MB. Okay, so I'm really sorry because I cannot do that. I don't have much data right now, and actually it will take much time. So you can do it by yourself. If you have much data, you can go to the this link, and if you want to share it, I will just paste it in the over here. Oops, I just forgot. So let me know everyone get this link, and whoever wants to try this mini cube, you can try. And tomorrow I will discuss about KubeADM, how to install Kubernetes using KubeADM. Okay. Any question? Or shall we wrap up the session today?
No, sir, Achyut, I'm good.
Okay. Anyone else? Okay. Thanks for joining. We will meet tomorrow at the
Okay,
same
Thank
so
time.
you.
thank you. Bye bye.
Bye bye.